Number 47. Write the balanced nuclear equation for the production of the following transuranium elements. And then we have dubnium-260, or dubnium, right? Made by the reaction of CF249 and N15. Okay. So we have to write a balanced nuclear equation, which means that we are going to use nuclide notation. Keep in mind that there are three things that we need for each notation. We need the element symbol, we need the mass number, and the atomic number. Now in this case, they said that dubnium, I'm going to call it dubnium because I think that's pretty cool, but dubnium-260 is made by this reaction. So if you're making dubnium, that means that this has to be a product. So the other ones, the actual reaction, CF249 and N15, those are your reactants. So let's start with our little blueprint, right? I like to have those boxes that look like this for each nuclide notation, but just as long as you have the three parts, you should be good to go. So we're going to have CF249, and they threw me a Californium in there. And my brain, once again, is just running rampant with songs that have to do with California, and the Californians from SNL. But anyway, CF249 plus another notation. We got the nitrogen going on here, N15. And we know that we're going to make dubnium-260, so I'm just going to add one more and see if this will be good enough as a balanced nuclear equation. But if not, we could add some atomic particles. But let's see how far we get. Okay, so let's start with CF249. So CF, Californium, is the element symbol, so I'm just going to put CF here. And now the 249 is the mass number. They do have to tell you the mass number because it can change for isotopes of the same element. Because you can have different number of neutrons, which means that your mass number is going to change. Now the mass number is always the top number of your nuclide notation. So I'm going to put a 249 up top here. But now they didn't tell me what this yellow part was, right? They just said CF249, but that is your atomic number. And atomic numbers do not change per individual element. It's their own unique special atomic number. They didn't tell you because they assume, the question assumes that you have your periodic table out and you can just grab that atomic number. Now the atomic numbers are the whole numbers in the periodic table. It's not the decimal values because that's the average atomic masses. But for Californium, it's number 98. Okay. Moving on to N15. We got a nitrogen. That's the element symbol, so I'm going to put an N here. 15 is the mass number that we have to call for, so 15. And atomic number for nitrogen all the time is number 7. I went on the periodic table and found it. Now, let's do dubnium, right? DB, maybe? Let's see, I'm going to search and search and search and search, and do I see it? Oh, no. Oh, yes, I found it. It is DB. So DB on the periodic table, it's in D block. Okay? And they're telling us that we're using atomic number 260. So I guess, right? 260. So we're going to put a 260 on the top. And then we have atomic number of 105. Right? Dubnium? Yep, 105. Okay, let's see if we have everything covered. Now, if this is a balanced equation, that means that the tops on the reactant side have to use the yield sign as an equal sign to 260 in this case. So we got 249 plus 15. So what is that? 249, am I going to just do it the old-fashioned way? 4, 1, 5, 6, 264. Doesn't match. So we're going to have to do something to get that to match. And then let's see the bottom numbers. 98 degrees plus 7. 98 plus 7. 8 and 7 is a 5. So that works. Just that the top numbers don't match. But that's okay. They said that this was the reaction, which means I can't really add anything on the reactant side, but I could add extra particles on the product side to get to what I need. Now, in this case, we did say that 98 plus 7 is already 105. And if we have a 105 already on this side, I don't want to add any numbers here. So this has to be a 0. But now, we said 249 plus 15 is 264. This will yield 260 plus what? What number should this be? Yeah, it should be a 4, right? But then I say to myself, what subatomic particle has a 0 on the bottom and a 4 on the top? None that I know of. But maybe I can kind of manipulate a subatomic particle to get me to a number 4 for the top number, right? What subatomic particle do you know, and it's the only one, that has a 0 for its atomic number slot? Did you say a neutron? If you did, you're absolutely correct. Neutrons have 0 for their atomic number because they're not protons, right? Protons is the atomic number. But just know that for a neutron, it always has a 1 for its mass, and lowercase n for a neutron. But now remember, we said that we needed 4, which means that I just need multiple neutrons. If each neutron is 1, how many total neutrons would I need to get to number 4? Yeah, I would need 4 of them. And if you need multiple neutrons, that's where you're going to stick that number right in the front. That's when we start adding coefficients. So if I needed 2 neutrons, I would put a 2 in front. If I needed 3, I needed 3, but I need 4, so I'm just going to, maybe I'll put it in different color, but I'm going to use big number 4. 4 times 1 is 4, and that's how you get the 4 technically on the top. 4 times 0 is 0, and that's why it doesn't change for the bottom number. And that's it. This is the final answer. What'd you think? Thank you so much for viewing the video. Subscribe to the channel and like the video. Just helps get the word out there that this educational channel exists. We're almost at 50,000 subscribers, and that's all because of you guys. So thank you so much for watching the videos, for supporting the channel, and we really hope we're providing great educational content for you guys to study. And it's always lovely when you guys can, study at your own pace, and that's why, whip out these videos wherever you are, and just study at your own pace, So, yeah. How many times am I going to say I don't know, But thank you, and I will talk to you soon, okay? I hope you have a great day, and keep studying hard. I believe in you. I'll talk to you soon. Bye-bye.